On this quiz, you're going to have 10 minutes, so we're going to go to about 9:20, 9:21, somewhere around that area. You can work with the partner, so get with the partner, do it real quickly, because otherwise you won't get finished. Listen closely so that you understand this. It's in the book, page 146, 1 through 9, and 12, on 1 through 4. On 1 through 4. Just give one line or one plane. You don't have to give all of them. All right? The directions say give all of them. I just want one line or one plane. Make sure you use your symbols. On questions 5 through 8, just give one pair of angles. So it asks for like the corresponding angles. Just tell me angle 2 and angle 7. Don't tell me all the pairs. Okay? One pair. That's all I want. And on number 9, just find the two angles. You don't have to explain to me how you found the two angles. Just find the measures of the two angles. Number 12, you do need to give a theorem. Give a reason. And that reason is going to be a theorem. Don't give me a number. Write it out. Don't give me a number. Write it out. So you might say something like this. If alternate interior angles are congruent, then the lines have to be parallel. You're going to write out something like that on number 12. Go ahead and begin. Number 5 said name pair of consecutive interior angles. Make sure you're using your symbol. Give me a pair of consecutive interior angles. 3 and 5. Everybody agree with that? Number 6. What's it want? Name me a pair of alternate interior angles. 3 and 6. Number 7. What's it want? Corresponding. Remember, you smash the lines together. Give me a pair of corresponding angles. 2 and 6. Everybody agree with that? Number 8. Let's see. Alternate exterior. 1 and what? 8. Is that what you said? 1 and 8. Everybody agree with that? Number 9. Number 9 said find the measure of those two angles. What can you tell me about angle 1 and that 138 degrees? We got to add up to 180. So somebody subtract that for me. What do you get? 42. How about angle 2? What is it? 42 also. And then number 12. Number 12. I've sent around several videos. I'm going to say this again just one time here so I can say it. If I send around a video and you see these stray marks, it just means that I did something where it didn't like it and it made a line. Just ignore it. All right, when you see those stray things, because I just start writing too quick. And are those two lines parallel? Yes or no? Yes. What kind of angles are those two to each other? So if consecutive interior angles are what? Angles are supplementary, then we know what? Then we know that you have parallel lines, or lines are parallel. I did have a blank slide there. I don't know if I did. I wrote it all in that little space. Title for today's notes, perpendicular lines. You got 2 papers, and we're going to use both those papers here in a second. But the first one is the one that's hole punched. It's going to go in your notes. This is the title, Perpendicular Lines. Perpendicular lines. Go ahead and start copying this. Write this down. Does anybody know enough about these? If I'm recording this, if I freeze this, will it continue to record?
I don't know.
So I probably better let it go.
I
It should record. I wouldn't think the two are together, but
Freeze it.
I think it'll just.
Nope, it stopped.
it stopped recording.
Yeah.
No, it froze the screen.
Oh, it froze on your computer.
I guess I'd have to go back here. Michael, don't let them laugh at you because did I walk over and look at the number counter too?
Hands left it, so it's better.
Yeah, it's still recording. If it's not going to be flashing, then I'm going to freeze it anyway. Seems to be holding. So again, this one that's hole punch, this is going to be part of your notes. We're going to do these 4 examples together. When we do these 4 examples, you probably want to write everything down to make sure you're understanding it because we're starting to get into a couple of sections here that are going to be challenging. Not easy. Got to really pay attention. So if you're daydreaming as I talk all the time, then probably not going to be good. Because it's not easy sessions. Write these notes down. Very good idea. How can you put that paper back there if you're going to write the notes somewhere else? Put it with those notes. It makes sense since they go together, right? What we're going to be doing, we want to find the distance from point Q to that line AB. If we're trying to find that distance, do I want to do this? Is that the distance from the point to the line?
Sure. I don't know.
Probably not. If you have a grandpa, you may have heard them say at some point, or great-grandpa, the distance as a crow flies. What's that telling you? You want to go directly to it. We want the shortest path so that when I'm looking at this, so that Gabe's not getting a different distance than Michael, who's getting a different distance than Nick. We want everybody to be uniform and get the same distance. So when we look at this, we want the distance from Q to this line that's going to be perpendicular. So it's got to form a right angle, right? And somewhere on there, shortest, you probably want to write something like this down. The shortest path always forms a right angle. The shortest path always forms a right angle. That's the path that we want, the one that forms a right angle. With distance formula, remember we're probably going to be on a graph. We're going to have stuff that's on a graph. How many points do you need to use distance formula?
4.
How many points? 2 points, right? 4 numbers need 2 points. Need 2 points to use the distance formula every time. So when we go to do this, I try not to do it anymore because they told me it wasn't a nice thing to do. If we put Haley out there and she's out in the desert somewhere, and she's gonna die of thirst before she gets to that road, which is AB. We want to get her there as quickly as possible, right? So what we don't want her We're not gonna call her on her phone and say, okay, you gotta go this direction. We don't want her to go that direction. She's not gonna make it. We want her to go the shortest path so that she can make it there. And that shortest path is always going to form a right angle with the line. Has to be that way. So if we want to find the distance for Haley to walk from Q to this road, we want that path right there. Because we want Haley to get there as quickly as possible. Because we don't want her to perish out there in the middle of the desert. Write this down. Slopes. This is all stuff reviewed from algebra, hopefully. Apparently I was too lazy to write this in. You might want to write the actual formula for slope. Actual formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I hate that formula because people turn it around, get it turned around, and then that messes up how they graph stuff. Because the slope formula takes the y's first and then x's second. Might also want to write this in there somewhere. Does anybody remember this from last year? Y equals mx plus b. Notice what I just say about that straight line going up through there. Doesn't mean anything. It's not a special equal sign or nothing. It's just my pen messing up. Y equals mx plus b. The m stands for the what? Slope. The b stands for the y-intercept. Good. The y-intercept. It's where the line crosses the y-axis. The y-intercept is where you always start at. That's where you're starting drawing your line if you have to graph it. You're starting at that y-intercept, then we use the slope to go from there. Hopefully your algebra teacher last year mentioned these two things. If lines are parallel, what do you know about their slopes? Two lines are parallel, what do you know about their slopes? They're the same, they're equal. Two lines are perpendicular, the slopes are opposite reciprocals. This is the one that everybody seems to have trouble with. They're opposite reciprocals. All that means you do is you change the sign. So if it's positive, you turn it to a negative. If it's negative, you turn it to a positive. And you flip over the fraction. So you flip the fraction over. So in this first example I put down here, I got negative 3/7. What's the opposite reciprocal of negative 3/7? Positive 7/3. You change the sign and you flip it over. These are if two lines are perpendicular. So if they're coming together to form a right angle, this one might have a slope of 3/7. This one's going to have a slope of, or I'm sorry, negative 3/7. This one's going to have a slope of 7/3. If you have a whole number, let's make up a different whole number here. If we have a whole number like 3 as our slope, you put a 1 under it so you can do the rise over run. And if we want to do the opposite reciprocal, we flip it over and we change the sign. Now, where a lot of people get themselves confused when they change the sign, if this was positive, this is negative. If I put the sign there, you got negative 1/3. I'm going to write this up here. Negative 1/3. Well, that's horrible. Negative 1/3. If I wrote it this way, is that any different? If I put the negative on the 1, is that different than putting the negative out front? It's the exact same thing. Don't make it, this is where a lot of students get confused. What if I put the negative on the 3? Is that any different? Those are all three the exact same thing. So don't let that confuse you. A fraction is just a number, whether it's a negative out front, negative on the 1, or a negative on the 3. It's one number. It's telling you that whole number is negative. So what if I gave you this equation? Y equals 1/4 x minus 6. What's the slope of that line? 1/4. Right? That's the slope. What's the slope of a line that's parallel to this line? 1/4. What's the slope of a line that's perpendicular to that line? You flip it over and change the sign, so it'd be -4/1 or just -4. You gotta be able to find all those things. Hopefully that's all a little just refreshing your memory from algebra last year. Next thing, get out this worksheet that's part of your notes. We're going to do those together. Give me just a second. I'll try to draw this first one up here. You've already got it drawn on yours. We'll graph some on the back. Let's see. Somebody help me so I don't have to keep looking at that. Tell me some points that they tell us on the first one.
Point B is
1, 2.
1, 2. Yeah.
So over 1 up 2.
Yeah.
Point B. Give me some others.
Point C is a x3,
3, 4. So out 3, up 1, 2, 3, 4. That's C. Give me something else.
A is -3, -2.
-3, -2. That's A.
You need to
C
protect.
is 5,
Huh?
You need to protect them.
Nah, I just need to report on it. And what? What's the other one?
-2. E is 5, -2.
5, -2. 1, 2, 3, 4, 5, -2. Ignore that. So we got this line. And they connect it somehow. Will they connect this to C like that?
Yeah.
Then they connect this over to there.
No. Connect P to B.
And then P to B.
No, they don't connect the P to.
P and
Oh, they didn't
A.
connect that one? All right. Doesn't matter.
You?
I am. So on this.
Yeah, they do.
Shh.
It's just hard to see.
They do?
Which is hard to see.
That's all right. It's hard to see.
Yeah.
On this, of these three, let's number them, 1, 2, and 3. Which one's the distance from P to that line? 2. You've got to make sure that you pick that out, because I guarantee somebody's going to pick this one. Oh, that's the distance. It's straight over there. Is that the distance that we want Haley to have to walk if she's trying to get out of the desert? Probably not. That looks like the longest distance. All right? This is going to be your distance from here to here. Well, if that's our distance, how are we going to find the distance from point P to that point B right there? What formula are we going to use? We're going to use the distance formula.
You need to do that thing where,
What's that?
I don't know what it's called, where you hit all the X's. Yeah.
Oh, calibrate it. Might do that here in a minute. So we got this. When we're using this, I guarantee there's several of these on the next test. When we're using this, all you're going to do is you're going to use point B and point P. Those are all you want, point B and point P. Somebody help me out and tell me the coordinates of point B right here. 1, 2. How about point P? 5, -2.
Yep.
Been a while since we did the distance formula. Remember, that's an X, that's a Y, that's an X, that's a Y. Have your calculators out so you can help me here in a minute. What are we going to put in place of the X spots here? 1 and 5. So let's put a 1 there, a 5 there. I would highly suggest that you're writing this down somewhere on that paper so you understand how to do these. I got my minus in here. What are we putting in for the y's? 2 and negative 2, Ben. Please don't spread my compass out like that. Otherwise, I'm going to take it away from you. If you spread it out too much, you're tearing it up. What do I do with this? A negative and a minus. Make it plus. I don't care how you do these. I usually do them like this. What's 1 minus 5? Negative 4. And I just write that down somewhere, and I know I still got to square that. What's 2 plus 2? 4, and I know I got to square that. What is negative 4 squared? Be careful. Positive 16. What's 4 squared? 16. What's 16 plus 16? 32. Now is where we need the calculator, because I don't know what the square root of 32 is off the top of my head. What is it? 5.65, so we'll say 5.7. Is that close enough? So how far is it from P to that line? 5.7 units. 5.7 units. If they give you the points and stuff, it's not really all that difficult. One's on the back would be a little tougher. Should be stuff you already know. Next one, on the next one, I'm not even going to graph the next one, just look at it. On the next one, what 2 points do we need? Tell me the 2 points that we're going to find the distance between.
From point P to.
Tell me the number. Tell me the coordinates. Negative 2, 3. Everybody agree with that?
Yep.
What's the other one? 2, 1. Everybody agree with that?
Yep.
I'm hoping that's right because I didn't even look at it. Now we're just going to use the distance formula. You're writing this one. This is the second one on the front of that paper. Distance formula. We subtract. That doesn't do any good for that. So we have that. What's our x's? 2 and negative 2. And what's our y's? 3 and 1. Now Michael said that we wrote these backwards. Does it matter which order we write them in? No, it doesn't make any difference, and I'd probably write that one second just so I can change that to a plus there. Maybe make it a little easier to do some of the math. What is 2 plus 2?
4.
So we got 4 squared here. What's 3 minus 1?
2.
So we got 2 squared there. 4 squared is what? 2 squared? 16 plus 4. 20. Somebody help me out. What's the square root of 20? 4.47. So 4.5. Is that close enough? So how far is it from those 2 points?
4.5 units.
4.5 units.
Now, were we trying to find P to R?
I don't know. What were we trying to find?
You were trying to find the right angle.
You want to be at the right angle because you want the
Okay.
shortest path, right?
Never mind.
So you want to be at the shortest path, so 4.5.
Okay.
Next one, flip over to the back. On the back, we have this point, negative 1, 2. And then we have this line, y equals 1/4 x minus 2. On this, you're going to have to graph these yourself. So you're going to draw yourself your grid here somewhere. Before I draw my grids, don't always just draw your grid right in the middle, because that won't always work out. All right? Look at the numbers and make sure you don't have any real big or small numbers. make sure it's gonna work to where you can fit it. Now this one, does it have any real big or small numbers? No, not really, so this one, it probably wouldn't hurt. Michael erased his already. He could probably draw it right in the middle. And that's not a big deal. So draw yourself a little grid there. Then we're gonna graph this point. Somebody tell me how to, explain to me how to graph that point. How do I move?
Down one.
Left one.
Left one, up two. As soon as we start doing slope, that's what everybody does. They do their points backwards. And I said this before, and nobody believed me, but on that first test, a whole bunch of people graphed their stuff backwards. All right? So remember, X tells you how to move left or right, Y tells you how to move up or down. Now, how do I graph this line? Where do I start at to graph this line? You start right there. Whatever that point is, that's where you start at. -2. That means you go on the y-axis, you go down 2 and you put a dot. The slope this time is 1/4. What's that 1 tell me to do?
Over one. What?
Remember, slope is backwards, right? Slope is opposite. Rise first, then run. So up or down first, then right or left. So you go up 1, don't say over. Right 4. You start at this point. You don't start at the origin. You start at the y-intercept. And that tells me go up 1, to the right 4, and put another dot. Then I go up 1, to the right 4, put another dot. Now I'm running out of space going that way, so how else could I move? Instead of going up and to the right, I could go what? Down 1 and to the left, 1, 2, 3, 4, put a dot, down 1 to left, 1, 2, 3, 4, put a dot, and you're going to draw in your line right there. Hopefully your line looks a little better than mine. Now once you have that line, we want to find the distance from this point to that line, but they didn't give it to us this time. We got to figure it out. We got to figure out where that path is. Am I going to make my path like to there? Probably not. That's not going to be the shortest distance. What I have to do is you must find the slope of the perpendicular. That's a perpendicular symbol. You got to find the slope of a perpendicular. Well, I know the slope of the original line is what? 1/4. So if I'm trying to find the slope of something perpendicular to that, I want the opposite reciprocal. So it's -4 over 1. You just flip it over and change the sign. Flip it over and change the sign. And what I'm going to do with that slope is I'm going to go to this point right here, and I'm going to move using that slope until I get to the line. What's this slope tell me to do? What's a -4 tell me? Down 4 and to the right 1. So I go down 4, 1, 2, 3, 4, to the right 1. Did I get to the line?
Yes.
Yeah, I hit it right there. So I went down 4 to the right 1. And I hit it. What do I know about this angle right here? That's a right angle. It's going to be perpendicular right there. And that means that has to be the shortest path. Now, how am I going to find that distance? Just count. 1, 2, 3, 4.
Distance formula.
You got to use the distance formula. Before I can use the distance formula, I need 2 points, right? Somebody tell me what's the coordinates of this point up here?
-1, 2.
-1, 2. Everybody agree with that?
Yeah.
What's the coordinates of this point where it come and hit?
Negative. Oh.
What is it?
-0,
0, -2, right? You go left or right, 0, down 2. Now I'm going to use the distance formula on that. Have your calculators out again so I don't have to do a whole bunch of this. What's my x coordinates this time? That's an x, that's an x, that's a y, that's a y. So what do I put in here in the x spots?
1 and 0.
-1 and 0. What do I put in for the y's?
2 and -2.
2 and -2, good. That's going to change the plus there, right? What is -1 minus 0? -1, what's -1 squared? 1. What's 2 plus 2? 4. 4 squared? 16. What's 1 plus 16?
17.
Somebody help me out. Square root of 17.
4.1.
Yes. Yes. 1 second. What's the square root of 17?
4.1.
4.1. Anybody agree with that?
Yeah.
On the next one, try graphing the next one on your own. Graph the point, graph the line. Try it real quick. Yes. Yep. Sure. Mr. McMillan, they'd like to see you in the office. Yay!
What?
Sorry.
Hey, for God's sake.
Everybody get the point graphed? So get the point, then try the line. Where do you start the line at? Start at the y-intercept. Slope's going to tell you how to move from there. You know, AJ's trying it. Ben, you might want to say the same thing that AJ said.
I probably did too. It's okay. What is it? Yeah. It's negative means this way. It's positive.
Somebody help me out. What's the point that they want graphed? -4, -4. 3, 4, Peyton. Focus.
Sorry.
So that's our point. What's the line? Somebody tell me. Why am I doing this way?
No, I think you should use the marker.
I know, but I can't record it if I'm using the marker.
Wait, has it not been recording this whole time?
Yeah, it's been recorded, but not for this one,
Oh.
because I started using the marker.
Why don't you get that looked at?
Look at what, like that?
You're bored.
The flashing? The flashing's the only thing that's wrong with it. Everything else, there ain't nothing you can do about it.
You need me to erase the marker.
You can see it.
Wait,
They
can
can see
you
it.
hear us?
Oh my gosh.
So, once I have this, I have my point there. Somebody tell me the line.
Y equals negative 2x plus 3.
2x plus 3. Where do we start at?
3.
Start at positive 3 on the y-axis. Start at positive 3. So you go up 1, 2, 3, put a dot. That's your y-intercept. I can tell it's bothering Michael, so there you go, Michael. What's the slope tell us to do this time? -2, 1. What's that tell us to do? Remember, it's
Down.
down 2 to the right 1. Down 2 to the right 1. So I go down 2 to the right 1. Shh. Down 2 to the right 1. Down 2 to the right 1. That's our line. Probably should draw more points than that, but I'm not going to. Now, we need to find the slope of something that's going to run from this to there and make a right angle. So we want the perpendicular. We want the perpendicular. Well, if the slope of the original line is -2/1, what's the slope of the perpendicular going to be? You flip it over and you change the sign so you get what? 1/2, 1/2. What's the 1 tell us to do? Up 1, and the 2 tells us right 2. So I'm going to go from this point, I'm going to go up 1 to the right 2. Did I make it to the line yet? So I keep going. Up 1 to the right 2. Up 1 to the right 2. Did I make it to the line now? Yeah. So I'm right there. We need the coordinates of this point. Somebody tell me the coordinates of that point. This one. Sorry. -4, -4. And now the points are the coordinates of that point. 2, -1. Now you're going to use the distance formula. Somebody tell me my x's. We're going to do this very, very quickly. 2 and -4. So 2 minus a -4, which is going to change that to plus. Tell me my y's or our y's. -1, -4. We'll change that to plus. 2 plus 4 is what? 6. 6 squared? 36. Plus -1 plus 4 is what? 3. 3 squared? 6? 9, thank you. 9. What's 36 plus 9? 45. That's all they needed? 45. Is that our answer, is 45? No, what do we got to do to that? Take square root. I see a lot of students who, and it's fine to work it down through there, just when you get to the bottom, don't forget to take the square root. What's the square root of 45? 6.7. Anybody else agree with that? So how far is it from that line to that point? 6.7 units, whatever it is. Set your notes off to the side for a minute. On the constructions, we're going to do these very, very quickly. Very quickly. So you're looking at this side. Everybody see which side I'm on? AJ can't see because he's too busy messing with his ruler and his protractor. Everybody see which side I'm on? That's the one that we're doing first. You're going to follow these directions. I'm going to try to help you on this little picture up here. First thing you do, you put the point of the compass on point P. The point of the compass. Not the pencil point, but the other. And you're going to draw a half circle. All right? And we want that half circle to intersect this line twice. So we're putting the point right here. And we want to draw a half circle down here so it looks hopefully better than mine. It's going to look something like that. No. So we're going to draw a half circle that intersects it twice. Half circle. And we're going to label these 2 points. I think they say label those 2 points, don't they? Label them A and B. So we're going to label them A, B. Then you're going to take your compass and you're going to put the point on A and you're going to draw an arc. You probably want to do it below. I don't have any space below, so I'm going to do it above. You're going to put your point right here, and you're going to draw an arc up here that maybe looks something like that, or down below. I do it down below on your paper just so you stay away from P. So it's actually going to look something, if I put it here, it's actually going to look something like this down here. All right, so it's going to look something like that. Don't move your compass. All
Oh, shoot, we literally popped. Yeah.
So watch, I'll show you up here.
I'm at 6.
So right now, we have this. This is A, that's B. Everybody got that much, right?
Yeah.
Now you're going to take your compass and you're going to put the point on A. And we probably want to be below, just because you have more space down there is the only reason I'm saying that. It doesn't really matter. But we're going to be below, and you're going to do this. You're going to draw an arc. Now you don't want to move your compass. Don't change the setting on your compass. Don't look at the numbers on your compass. Oh, it's a 2. That doesn't matter. What matters is that you just don't move it. And you go over to B and you do the same thing.
Does it intersect the...
And those two should do what? Those two should intersect. That's what we want. We want them to intersect. You got it right there. That's the point that we want. So those two intersect. Where those two intersect, they say label that point Q. So these two are going to intersect down here somewhere. And we're going to label that point right there point Q. Does that make sense to everybody so far?
Yeah.
Now the next thing says, draw line QP. How are you going to draw line QP?
Draw a line.
Take your ruler and you're going to draw a line that goes through Q and P. Mine there didn't work out too well because I wasn't using a ruler. I'm going to come over here. Oops, mine didn't work out very well there either. I missed Q completely, but you get the idea, right? It's supposed to go through that point Q down there. Then the next thing, they want you to take your protractor and measure this angle right here. What did it come out to be? It should be a right angle. If we did everything right, these are the directions to form a line that's perpendicular to the given line. A line that's perpendicular to that given line. If we did everything right. Yours should be fairly close. It might be a little off one way or the other because my tools that I gave you aren't the greatest. Looking at the second one. Flip over on the back. You're going to spread your compass. So it's more than half. Is that more than half of my segment? Does everybody agree that that's more than half?
Yeah.
So you're going to spread it so it's more than half. Doesn't matter how much more or how much less. Just don't make it so big that it's off the paper or anything else. Probably work more than half. And you're going to draw an arc. Let's see. Let me read before I put compass on point A and draw an arc that crosses the segment. So you're going to draw an arc like this. You're going to draw an arc that's going to come around like that. Don't move your compass. I didn't put it this time. Don't move your compass. Then you're going to do the same thing on point B. You're going to put it on point B and you're going to draw another arc. And you want those two to intersect at two separate places. So mine intersects something like that. And you're going to label those 2 points. What they say label them? P and R. Is that right? It says on P and R. Label them P and R. Then they want you to do what? Draw that line. So you're going to connect those two. You're going to connect them. And we're going to label this point right here in the middle. We're going to label it point M. Point M. Anybody tell me anything about segment AM and segment MB? They're the same. M's going to end up being the midpoint there. So it split that segment into 2 equal parts. Anybody tell me anything about this angle right here? It's a right angle. Those angles are going to be 90 degrees. Math people, very, very creative, and we're going to jump back to your notes here in a second. Any idea what they call this line that we just drew in there? What's it do to that segment? It bisects it, and it's what? Perpendicular to it. Guess what math people call that? A perpendicular bisector. Math people, very, very creative. It's a perpendicular bisector. Perpendicular bisector. Go ahead and write this down very quickly. We got this, and we got 3 theorems that you're going to write down. We got to do it fast. So Ben, you can't sit there staring off into space. You need to be writing. So a perpendicular bisector is a line that's perpendicular to a segment and bisects that segment. It's perpendicular to a segment and it bisects that segment. You might want to stick on there somewhere that this is very important. Because if I can write something this short, where I say AB is a perpendicular bisector of GK to give you information, that tells you a whole bunch of information, and I only had to type just very few letters. And that's, so I like using stuff like that. What's it tell us about all 4 of these angles right here? They're all right angles. What's it tell us about these 2 segments? They're congruent. That one little short sentence told us 6 things about that picture. So AB is a perpendicular bisector. Perpendicular bisector. So you got it. Next, 3 theorems, just real quickly. The first one, I'm going to go over them. You can start copying them. If I tell you that these 2 are congruent to each other, what's the measure of each one have to be? 90 degrees. That's the only way it works out, right? 90 plus 90 is 180. That's the only way it works out. The next one says, if these 2 lines are parallel, that's a right angle. Guess what you know about all the rest of the angles in this picture? They all have to be 90 degrees. They all have to be right angles. And then the last one is just the converse. These 2 are converse of each other. The last one just turns it around, and it says, if that's a right angle, then we know that those 2 lines have to be parallel to each other. The assignment's written over here on the board, so when you get done writing down those notes, you can copy it from right there. If you want to take a picture of it, that'd be fine. I don't have any problem with that. Make sure you have the assignment written down. put the rulers, compasses, protractors back in the boxes where they belong, please. Hey, Michael, while you're up here, will you click the board for me? Like, what do we do? Just click the white, the screen.
Over here on top.
Michael, click it one time. Try it again.
This is dragging.
Keep trying it. It's not, I don't know why it's not moving. Oh, it won't move. That's right, I'll get it.
You could have used this winner.
Only sweet and sour?
Well, like bourbon
Zoe, there's a brand new pencil laying there. You need it? Oh, that's Michael. Sorry, Michael. Having Zoe steal your pencil.
See ya.
Have a great day. Is that yours?
Have a good day, Mr. Russell.
You too, girls.